What is the signature for post order? Is it same? So let's copy one of them and say this is going to be post order traversal. After that we make a copy of this in traversals.c. Where is traversals.c? First thing we need to do is we need to check for root. If root is null, then nothing to do. Similar to what we have done earlier. And let me copy this message also. And we call it post order traversal. We need a stack for this. So we create a stack, star s is equal to create stack. And in the end, destroy stack also. So now we have to do our work. So we begin with an infinite while loop. That's where we want to carry out the logic of traversal. So till this point it is similar. So let's also take a temp variable bst node, capital BST, star temp equals root. We will need one more, but we will add that when the need for that arises. So what is the first thing we are doing? One while loop to go to the left. So while temp not equal to null, because we don't want to push null. What we are doing? Push s comma temp. That is what we were doing earlier, but here we have to do one additional thing, because we want to come back to the root from left child, and then we don't want to print it. We have to go to the right also. So we should do push s comma temp ka right. Is this statement correct? Don't need to put any check here. What if right of some node is null? We don't want to push a null. So we should put a check if temp of right is not equal to null, only then we push it. And after that we push temp. Do we need to put a check before pushing temp, whether temp is null or not? That is already there in the while loop, so not required here. And because we have checked for temp nullability here right also will never crash, because we are never entering the loop with temp null. And after pushing right and temp, we move to the left of this. Temp equals temp of left. So this way, moving to the left, we are covering using this loop. Now we will come out of this loop when we reach a node whose left is null, because temp becomes null. Now we are at leftmost node which is null. So temp becomes null after this loop. So what we do? Next thing that we do after coming out of this is we pop. Because temp is null, we want to pop the top element of the stack, because that is where we want to begin. So in our case, till current case, once we reach 0, that's when after 0 we move to the left, it will become null, and that's where the loop will come out. The temp will be pointing to left of 0, which is null. After that we want to pop 0 out, and then we want to check should we print 0 or not, and that decision will happen based on the previous element that is pushed onto the stack. If 24 is there pushed onto the stack before 0, that means we cannot print 0, we first have to go to the right of it. So let's pop our first element. Temp is equal to pop of s. Now we want to pop one more element. So for that we will need one more variable, bst node star, let's call that p. So second pop we perform pop of s. Now we need to include a check before printing. Now printing or not printing will depend on the check. What is the check? If P equal to temp of write, is the statement correct? P is a pointer of type BST node. Temp of write is also a pointer. So can we compare these two pointers? Yes. So if P is temp of write, what does it mean? We cannot print it, right? Because write was already there. So in this case, we proceed with the write subtree. So can we say temp equals temp of write? Because that's the next pointer we are setting, and this loop is totally running on this temp pointer. We are just saying once we encounter 0, we pop 0 and 24 from the stack. Now we don't want to push 24 back because write we are anyways going to cover, but we want 0 back onto the stack because 0 we still have to print. So we will proceed with our temp pointer will set to 24 so that it can go and keep on pushing all the elements in the write subtree, but 0 we have to push back. So before going to the write, we'll say push S temp. Now the write is popped. On stack we have 0 without its write child. That means next time we pop 0, we can directly print it. Now only thing left is you have to fill the else part. In else part, what should we do? We want to print it. There is one element we want to push back because we popped 2. Write also we popped. So if the write child was not there on the stack, we have popped something else, right? So before 0, if its write child was not there, someone else might be there, and we have popped that. That we should not have outside. We should push that back. So in this else part, you fill the logic, fill the code, try to run. So what goes in this? In else part, if you notice, what we are actually doing is, let's take a look at this stack. Initially, we would have pushed 67 because that is write of 41. Then we would have pushed 41. Then we would have pushed 36 because we come to the left. 34 is having write child, so we push write child first, then 34. Then we push 0 has write child 24, then 0. This is the stack we have till now. So after this first loop gets over because temp reaches null, then we come to popping. So we do 2 pops. First pop will pop 0, second pop will pop 24. So we have, in temp we have 0, in P we have 24. Now we are checking whether 24 is right child of 0, which is true. So what will happen in that case? We don't put 24 back onto the stack. 24 is gone. 0 we put back because 0 we have to come to again. And then we start again with temp is equal to temp's right. What is right of temp? 24. Or we could have also said temp is equal to P. One and the same thing because it is the right child. No difference here if we write temp right or P. Then we'll go on top of the loop again. Till now no printing has happened. On top of loop if we go, there is a while loop there. What is temp pointing to? 24. In that while loop, what will happen? 24 has a right child, 27. That will be pushed first. So after, okay, let me draw that stack here now. Above 0, here it is 0. Then we are pushing 27, right child of 24. Then we are going to push 24 and we move to the left of 24. What is the left of 24? 5. So we'll check if 5 has the right child. It does not have. So we push 5. Ultimately 5 goes there. Now after 5 it moves to the left of it. That is null. Now stack is in this state. 24 has come back again, but 24 is not before 0, which tells that next time we encounter 0, we can directly print 0. Now this again while loop is over, we come back and pop 2 items. What are the 2 items we pop? 5 and 24. So temp will have 5 and P will have 24. Is 24 right child of 5? No. So we don't have the right child here. So what indication does it give to us? We can print 5. Its right is already covered. So in else part, the first thing we can do is we can directly print temp ka data. So 5 will be printed. We also popped 24. We should put back 24 onto the stack because 24 is yet to be printed. We should not remove items from the stack, otherwise those nodes will not be visited. So that also most of the people have done. We have pushed 24 back onto the stack, 5 is no more going back onto the stack. After that, the next question is, what should temp be pointing to? So if we say temp will point to 24, what will happen? We come to 24, the top while loop, it will again go to the left of it. That while loop will happen. If it has a right child, that will be pushed. If it has a left child, will go to the left. But that we don't want. What is the next thing we want from here? First loop we don't want to execute, right? So what is the condition in which first loop will not execute? If temp equal to null, and we want exactly that. We don't want this to execute. Next again we want the next item to be popped. So what should we do? Temp should be set to null. So that's the only catch. Temp should be set to null. Before this we should be printing %d space temp ka data, and we should be pushing back si of p. So the extra item that we have popped, we are putting that back. So these are the 3 steps that are required in the else part. And in case you want to debug, you can also set temp is equal to p, because that is what most of you had written. If you set that, you trace it, you will find every time it is pushing items onto the stack, which becomes a problem for us. Next we want is pop the item and start with that. With this, let's try. Even now I am not sure whether it will run or not, because our mind said this is the correct logic, but we still want to add it to unit tests. So in main we added a unit test, traversals unit test. In the end I am pasting this function with root, so that along with all other traversals we also print post order. Now let's try to compile it. So compilation, it worked. Let's try to run it. Crash. Now what is the reason for this crash? Ajay, what is the reason for this crash? It's there in this window that I have left here. What did we miss? Temp of right. No, but temp we are popping, right? Whenever we pop, we are never pushing a null item on the stack. If we pop anything out, temp is not null, so we can access temp of right. There is something in these lines. Yeah, Rushank is right. So we are not checking stack is empty continuously. This is an infinite loop. Even after stack is empty, we are going to pop, right? Oh, you have put that? You have put only before first pop. Second pop also need to have that check. So these 2 checks. Right now our loop is infinite loop. It will keep on popping elements even if stack is empty. So the assertion that was hit was stack is empty and we are doing a pop. So what is the check we should put? Before popping the first item, we should check if is stack empty s, we should simply break. Now we are doing second pop also. What if we did the first pop and then stack became empty? When we pop the last item from the stack, now if here stack becomes empty, that means there is no other item to pop. What should we do here? So we let's say first pop the last item. Any item that is there on the stack, we need to print that also, right? Last item means that will be root, the root of the tree, because its left is done, its right is done, only that item is left. So in this also we should put a check, but before coming out we should be printing that item, temp of data, so that root is printed in the end. Yeah, yeah. Root doesn't print if we don't put this printf here, right? So if we don't print this, that means you have popped the last item. After that you checked stack was empty and you came out of the loop. So that we have to make sure, if this is the item when you pop and stack becomes empty, you print this and come out. If you print this, root will be printed. So these two checks are also important. Now if we try to run, it will give us valid post order.